right, so Workplace 30, Chapter 6. We're talking about transformations here. And your test tomorrow is going to be on transformations, going to be on rotations, and it's going to be on dilations, so enlargements or reductions, and then, of course, combining all that together. So I want to just go over the highlights for Chapter 6 here. All right. Single transformations is where you started in 6.1. And just as a reminder, and again, you can have your notes out and write down some notes, do some highlighting. For those of you in my class, you may have a cue card or a cue sheet for your test tomorrow. So it's not an open book per se, but you can have a cue sheet if there's anything you want to write down to remember. So while we do our review, you can certainly highlight some things, or you can be making your cue sheet, okay? So a transformation is the movement of a shape or an object by changing its position, size, and or shape, okay? So that's what a transformation is. It's just making something larger or smaller or moving it, that sort of thing. So there are types of transformations. A translation is when we just move one object from a certain position to another position. So either we're sliding it over or we're sliding it up or down, and that's what a translation is. Think about language. When you translate from one language to another, you're just moving the exact same message from one understanding to another understanding. So you're not changing the meaning in translation. You're trying to get the exact meaning, just move it over to a new language. So that's what a translation is. A reflection, okay? A reflection is where we would draw a mirror image. So it's kind of like a flip, right? A reflection is like a flip. So it's not a movement, it's a flip. So think about it. If you have your hand over here and you move it, your thumb is still, on this, for your viewing here, it's on the left side. If I were to do a flip or a rotation, let's try this. Okay, a reflection, then the thumb is on the right side. It's on the opposite side. So your hands are mirror images of themselves. So two hands like that, the reflection line would be right in between the thumbs there, right? The reflection line right in between the thumb and fingers there. So that's what a reflection is. And the reflection line, of course, is sort of like the mirror or the line by which the image has been reflected. Okay, so if you have your two hands like this, let's see if I can get around here. Two hands like this, and if I were to open them up like this, the reflection line is right between my thumbs there. And let me know if you have any questions, okay? You can just jump in if you have any questions while I'm reviewing this. All right, a rotation. Obviously, a rotation is when you take an object and you spin it around a certain point, right? There's a certain point. That point can be on the vertex of an object. It can be far away from the object, and you spin it around that point. The whole thing moves. So that's what a rotation is. In this case, this triangle is rotated about the origin. The origin happens to be where one of the vertices are, and so it's just kind of rotated, flipped around here like this. How do you tell how many degrees it is rotated? Well, an easy way to do that is to take one of the sides of the object, let's say that one, and find the corresponding side. This one's a bit tough, but you can see the corresponding side is down here. And you kind of measure the angle that's formed between those two sides. That's a 90-degree angle, so that's a 90-degree rotation. If you wanted to rotate this 180 degrees, well, then you'd have to keep going so that this line here forms a 180-degree angle. Okay? Whatever that is. Okay? Any questions there so far? About reflections, rotations, translations? Okay, again, you've kind of been through this already, so I guess the last sort of thing that we need to understand is a dilation, and that's like a reduction or an enlargement, right? So if we have a scale factor that's greater than 1, we have an enlargement of something. So this box right here, this rectangle, if this is the dilation over here, it's been enlarged by possibly a factor of, maybe almost double, right? Not quite 2, but it looks like this side here versus this side is maybe 1.5 times or 1.7 times. So that's an enlargement, okay? A reduction is also called a dilation. All right. So working with translations, this is a question that you're going to get asked, is to move this shape a certain way. So 6 units to the right, 2 units down. And what you do is you take each point, let's start with A, and you would go 1, 2, 3, 4, 5, 6 units to the right, 1, 2, 2 units down, and there is your image point. We usually signify the image points by a little prime signal or a little tick mark there. So A becomes A prime. And you do the same thing for B. So you count over and down, and then you would draw, you connect all the points, and I think I have, oh, maybe I don't. Let's see, I wonder if I have that solution. Oh, I must have skipped. Let's try that again. Whoa. Skipped a few pages there. 219, okay, do I have 220? I don't think I do. So let's go over to the workbook here. Let's try and find 220. So for you guys, let's see, 230. Okay, so 220 right here. So that's your finished product right there, right? 6 units over, 2 units down for each point. And notice that in a translation it's the exact same size, okay? And if it's a translation, you're moving it left or right, or up or down, or a combination of any of those. So you're not twisting it, you're not stretching it, you're not making it bigger or smaller, and you're not rotating it. You're just taking the shape and you're moving it either in, one of 2 directions, up, down, or left, right. Make sense? Okay, as we move through here, this question, I noted this page because this is a good question here to ask. And the question says, which shape 1, 2, or 3 is a translation of ABCD? So here's ABCD, this parallelogram here, or sorry, this quadrilateral. What is a translation? So if we look at these, remember that the translation has to be the exact same shape. It cannot be twisted or enlarged or reduced or warped in any way. And so if you look at 2 and 3, those are not the same shape as this one. Only the number 1 is. So this, number 1, is the translation. And if we check to see how it's been moved, you just take a point. You can just pick one on the original diagram, like for example, point C, and then find the corresponding point on the image diagram. So that's obviously the tip over here. And you count 1, 2, 3, 4, 5. So 5 units to the right, and 1, 2, 3 units down. So that would be your answer. So if you get that question on a test, you'll be able to identify that. You guys good? Any questions so far? Okay, working with reflections. As I mentioned, just pretend that the line of the reflection line, is a mirror. And this letter R here is looking in the mirror. So this side right here that starts at the mirror and goes 1, 2, 3, 4 units this way, well, the reflection image goes 1, 2, 3, 4 units the opposite direction. Okay? And everything is exactly opposite. A part of the image that's on the reflection line stays on the reflection line. And you basically just connect the points. And so this one here is 1, 2 units up, so 1, 2 units down. And so I would draw like this. Rounded ones are a little bit tricky. Look at this though. 1, 2, 3 units is where the peak of that round is. So 1, 2, 3 units. So I know I have to go up here and then hit that point and then come back there and so on. And the little hole in the R is 1, 2, 3 units from here. 1, 2, 3. So that's the middle of the little hole. So again, you just kind of want to do your best. And that appears to be the reflection. Okay. If I drew the line over here, right here, right, then the reflection would look quite a bit different. You would do the same thing though. You would count how many squares, pick a point, count how many units from the reflection line and go the opposite direction. 1, 2, 3, 4, 5. So I go 1, 2, 3, 4, 5. Let's say that's over there. And that point would be over here. Okay, and so on. So I won't maybe do the whole thing, but it would look something like this, right? Let's say something like that. That's not quite right, but you get it. So it would reflect. It would be a mirror image there. Questions? All right. Okay, so write your first name in capital letters, then reflect it over a horizontal reflection line. A horizontal reflection line, my name would be pretty easy. I'll just do Mr. M. Horizontal reflection line, I am, down and that. I'm pretty much Worcester W. Mr. M is Worcester W. So, reflection. Does that look good to you guys?
Yeah.
Look okay? All right. So, again, here's if you've ever been to the mountains and to a crystal clear lake, you can see the reflection of the mountain and the lake, and there you go. There's your reflection line is the shore. All right, moving right along. What's next here? Did I hit something on this? Okay. All right. So, if I take a look at ABC here, this over here is a reflection about the or around the y-axis. You see that? It's reflected this way. Spun right around that way, left, right. This one here is a reflection of this original down around the x-axis. So it's reflected about the x-axis. So they kind of look like, in a sense, they kind of look like rotations, which we're going to kind of take a look at next. But these are clear reflections. Sometimes rotations and reflections can look very similar. So you have to just watch carefully. All right, so if we, you get a question where you'll ask to be, to reflect around an axis. A line of symmetry is something else you need to understand. A line of symmetry is like that reflection line, except it's a reflection line that's within the object itself. So if I were to complete this diagram very hastily here, it would look something like this, maybe. I'm just guessing here, so let's see, is this looking okay so far? Is that 1, 2, 3, 1, 2, 3? Ish, okay, yeah, it's tough with this tablet actually. But the reflection line is right through the middle of the star. That's also called a line of symmetry. So in this question number 11, right, we have lines of symmetry in these flags. In our Canadian flag, you can draw one right through the middle here, up and down, okay? Because if you were to fold it over on that reflection or that line of symmetry, it would exactly map onto the other side. The UK, okay, we've got reflection lines all over the place, here and here. This is not a reflection line though, because it's a rectangle. If you were to fold it over here, because it's not a square, these points wouldn't line up. This point would fold right over to here, and this point would fold right over to here. So be careful with the diagonal ones. Whoa, what happened there? I just want to get rid of some things. Okay. All right, so so we've got this one here for India, Australia. Okay, I can't really tell all the colors, but so you can see there's definitely reflection lines. South Korea, what about South Korea? All of these four parts are different, and it's really tough to draw a reflection line through this symbol right here, isn't it? Because it does not fold over onto itself, it doesn't map over onto itself. So even though it looks like there's reflection lines here, because all these four are different right away, it won't map onto itself. But generally, if you kind of blur your eyes, it looks like it might fold a little bit.
In the question, it says to look at the shape, not the color.
Okay. So if you don't do the colors, then that's fine. Still, the shapes are no good here, and this symbol, there's no line of symmetry in this symbol here in the middle. And you're not in this class.
I mean.
So keep going on your class. Okay. Thank you. But nice notation. But, okay. Rotations. Now rotations, as I mentioned, the flips about the axes and the rotations sometimes can look very, very similar. But rotations, I kind of did mention here earlier that if you took one of the sides or one of the portions of the unit and or of the object, and you rotated it, let's say 90 degrees, then about the origin, this is your pivot point, you'd have to go 90 degrees over here, and that's where your line would be. Now, sometimes that's hard to do, so just as a refresher here, okay. So if you're gonna count this, you're gonna go 1, 2, 3 up and 1 over, let's say. Well, then you got to move this whole pathway 90 degrees over, which is a little bit easier to envision. 1, 2, 3, and then one down. You see, that's 90 degrees. So your side looks like this. Okay. So then you could do that for each one, and although it gets a little tricky when you're doing BC here, right? Because you're not rotating about here. But still, this side would have to rotate. It'd have to connect to this point right here. And you could go 1, 1, 2, 3. So what is that going to mean? Well, if we go up 1 and over 3, let's go, let's do, what is it? It's going to be 1 and 3 this way. So 1 and 3 and so on. So note that this side here, and this side here, even though they're not connected, they should form a 90-degree angle too if it's a 90-degree rotation. So every corresponding side in a 90-degree rotation should form a 90-degree with its corresponding side on its image, if that makes sense. So this one here is going to be 90 degrees, something like that. You see? Going to make a right. And this one here is going to make a 90-degree there. Okay? So they all make 90 degrees with their partner or whatever. All right. Any questions about that?
I have noticed that.
Yeah. Okay. All right, so just so everyone, for that question there, the question was, what are the quadrant names? So this first quadrant is first quadrant, and all the points here are positive x and positive y. Over here is the second quadrant, which we have negative x values and positive y values here. So you go left and then up. And over here it's negative, and over here it's positive and negative. The coordinates of all the points in these quadrants. So 1, 2, 3, and 4. Okay, we'll keep going here. Rotations, again, we just started talking about rotations. So let me just kind of finish here. 90-degree rotation is 1/4 of the way around a circle, right? It forms a 90-degree. 180 is halfway around the circle. 270 would be, like 3/4 of the way around the circle. So if you had a line like this, right? So here's 90, there's 180, here's 270. Going all the way around, that's 270 degrees, right? And then 360 degrees would be a full rotation. So for this one here, going 90 would be to this one, and 180 would be mapped onto this one, and then there's 270. Okay? Now I'm not sure if in any of your questions they asked you to rotate in a negative direction. So I'm not sure if that's going to be part of your experience or not. I don't know if there's anything like that, but negative would be simply, instead of clockwise, it would be counterclockwise. So this would be negative 90. So positive 270 degrees and negative 90 would be the same. Okay? Just as a note. All right. So here's some practice, and again, this would rotate around. If your origin, that's the 0, 0 mark, right? And I think I did this the other day. I showed you on the video, but if we have, where are they? So if we have two identical, so if we have an object and you're asked to rotate it, right? So let's say there's the object and you're asked to rotate it. Well, 90 degrees would rotate this way so that they form a 90-degree angle at corresponding sides. If you have a rotation that's away from the origin, so let's say we have this, actually let me try and make that the way you can see it on the, okay, so we have this, and we're asked to go around the origin. It's going to look something like this, where it rotates around. See, it's not connected, right? It's going to rotate around. So we're going to go there's about 90 right there, right? Or about there, 90. And then kind of 180 is about like that. So, all right. All right, dilations is the last sort of transformation that we want to talk about here, really. And dilations are, as I mentioned before, enlargements or reductions. So if you have a scale factor that is greater than 1, that means we have an object that is larger. Okay, if the scale factor is 2, that means the object is exactly twice as large, or each dimension, so each side, let's say, would be twice as long if the scale factor is 2. That's how it's calculated. If the scale factor was 1/2, that means from the original, the model is 1/2 the size. Each dimension is 1/2. Okay? Similar means that they're the same shape but different size. That's what similar means. Same shape, different size. Okay? So when you're building a model of a house or building a model of a car or something like that, and you have the exact same shape but it's just smaller, that's a reduction, okay? That's a scale. So we talked about questions like this last class, I think. A scale of 1 to 100, so that would mean like 1 centimeter is the equivalent of 100 centimeters in the real object. 1 to 500 would be 1 centimeter is equivalent to 500 centimeters in the real object. So 1/500th is a smaller model than a 1 to 100th. Okay? Because for each centimeter, it represents something that's bigger. So it's a smaller model, let's say. Okay. 6.2 is multiple transformations. And again, if we do a rotation and a translation, or if we do a reflection and a dilation, it's just combining the two. So you've had some practice with 6.2 in combining different things. Yeah?
It doesn't really matter which order you do it in.
Well, generally, okay, the question was, it doesn't matter what order you do it in. I think what they'll do is they'll tell you the order in which you're supposed to do it, really. Like, reflect the shape over the y-axis, then over the x-axis, what are the final coordinates? So they'll usually tell you, rotate 90 degrees, then translate it 6 units to the right. So you don't have to worry about what order to do it in, because I think they'll tell you. Generally, if they don't tell you, generally you would do the stretches and dilations first, and then you translate at the end. But I don't think you're gonna have to worry about deciding your own order. Okay. So again, when you do your transformations, when you're all done, the question may ask you to give the new coordinates. So remember that if the A vertex is on the original diagram, the image point of A, or where A transforms to, would be A prime. We call that A prime. And so that's how you signify which is which. Okay? So the image has these little tick marks. The first image point would be 1 tick mark. The second image point might be 2 tick marks, and so on. Okay, any other details leading up to this exam that you think I might have missed or you have questions about still? Okay, so chapter 6 is all about transformations. There's your in-depth review for your upcoming exam.